All right, so this is the second video of the problems that you guys are going to be working on. So what we're going to do here is we're going to do a couple of examples that use both the sum of the angles theorem, angles add up to 180, and the exterior angle theorem, where the angles add up, the two angles that are not touching it inside the triangle add up to equal the angle outside of it. All right, so question number 4, find the measure of the angle of Pittsburgh. So we're trying to figure out this guy right here. So how much is Pittsburgh? That's the question. Now we'll notice that Pittsburgh is an angle that's inside of the triangle, so we're going to use the angle sum theorem because all these angles are inside of the triangle. So we can say that if we take the 85 degrees and we add it to the 52 degrees and we add it to Pittsburgh, so I'm going to put P for Pittsburgh because it is the only one up there, this right here is going to have a total sum of 180 degrees. It's applying the theorem. Now I'm going to add these guys right here. This comes out to 137, so we get 137 degrees plus P is equal to 180. Next, we're going to subtract the 137 to both sides of the equation, and this results in P is equaling 43 degrees. So we now know that Pittsburgh has a measurement of 43 degrees. Question number 5. Find the measure of the angle from the star. Now this is a really bizarre question to ask. Find the measure of the angle from the star. I am talking about this right here, this angle. How much is this angle? So what we're going to do is the same exact premise. We're going to add up all the angles because they're all on the inside. So this angle here, the one we don't know, we'll call this guy x. So we'll say that guy's x. So we're going to say x plus 62 plus 19. So write this down. X plus the 62 degrees plus the 19 degrees. All of those angles have to add up to equal 180 degrees. Collect like terms. We got 62 plus 19. This is going to come out to 81. So we have 81 degrees. X plus 81 is equal to 180. The next step is to subtract the 81 from both sides. This means that x is equal to 99 degrees. So we know the angle of the star up there, the angle at that star is going to be 99 degrees. Moving on, question number 6. Now question 6 is a little more advanced. Question number 6, by the way, just thought I'd say it now. If I am going too fast, go ahead, pause the video, rewind it, slow it down, and then go back and do it. Problem number 6, another example, find the measure of each numbered angle. We have angle 1, 2, and 3. Now 1's a little tricky because 1 is on the outside of the top triangle. It's also on the outside of the bottom triangle. So I'm not exactly sure where I should be going with angle 1, except that in the top triangle, I have two angles that are not touching it. So what I can say is that the 23, if I add it to the 32, so if we add these two angles here, that should add up to equal the angle 1 on the outside. That's going to equal the measure of angle 1. So now I can add these two guys up and I get 55 degrees. So I now know that the measurement of angle 1 is 55 degrees. So this guy right here is 55. So 55 degrees right here. And then this is where it gets a little complicated. In the second part of the problem, what I notice is the 55 degrees is not touching the 22 degrees there and the angle 2 right there. You'll notice the angle 1's not touching that. So what that tells me is I can say that the angle 1, I can say that the measurement of angle 1 is equal to the 22 degrees added to angle 2. So I can say that it's the measurement of angle 2 added to the 22 degrees. Now, since we already found out what angle 1 is, we can go in and substitute that. So we can say that this right here is 55 is equal to the measurement of angle 2 plus the 22. We solve this by subtracting 22 from both sides, and we get 33 degrees is equal to the measurement of angle 2. Now I'm going to go ahead and erase some of this stuff here because it's kind of getting in the way. So I'll erase the, oops, sorry, maybe I won't erase it. So now what I'll do is I'll say that angle 2 and angle 3, these two angles right here are kind of like a linear pair. So angle 2 was right here, right? So you see it right there. And angle 3 was right there, which means those two angles have to add up to 180. So now I can say that the 33 degrees added to the measurement of angle 3 has to equal 180. And then subtract the 33 from both sides, and we get the measurement of angle 3 is equal to 147. So now we have 147 degrees for angle 3. Moving on to example number 7. Example 7, find the measure of each numbered angle. We got angle 1 and angle 2. There's two ways to do this. The first way is you can use the exterior angle theorem. So what I can do is I can say, okay, since I know that this guy's the exterior, then angle 2 and 65 have to equal 90. So I can say the measurement of angle 2 plus the 65 is equal to the 180. But I also have that these three angles on the inside, the three angles on the inside over here, I can say that the 25 degrees added to the measurement of angle 1 added to the 90 degree, the right angle, that little pink box right there, has to equal 180. And now I have two equations, one for the interior angles and one for the exterior angles. Now both of them are going to give us two different angle sets. So this guy over here is going to give us our angle set for angle 2, right? So this one's going to give us for angle 2, and then this one here is going to give us for angle 1. Now we can solve this guy here. We can say the measurement of angle 1 plus 115 is equal to 180. This means that the measurement of angle 1, we subtract the 115 from both sides, and we get 65 degrees. So we now know that angle 1 is 65. Angle 2, we can say the measurement of angle 2, subtract the 65 from both sides, is equal to 115. And we now know that, my mistake. Over here, I made a big mistake. This is not correct. Angle 2 plus 65 does not equal 180 because they're not linear pair. Angle 2 and 65 are interior angles to this guy. This should have been a 90 degrees right there. That's a mistake. I'm sorry about that. So let's go back and fix this guy over here. We can say that we subtract the 65 from 90 and we get that the measurement of angle 2 is equal to 25 degrees. So go back and fix this. I'm sorry about that equation right there. So go ahead and cross it out, erase it, it's up to you. But we now have both of our angles. All right, last problem. This guy here is kind of a goofy one. It's just this skier kind of chilling. He's, I don't know, doing the long jump or something. But his body will form an angle right here where that's a right angle. Now we need to find the measure of angle 2 and angle 1. What we know, so in the textbook, I'll make it up. What we know is that angle 1, measurement of angle 1 is equal to 17 degrees. So if this skier can make a 17-degree angle, how much is angle 2? Now, since all three of the angles are inside of the triangle, we can say that the measurement of angle 1 plus the measurement of angle 2 plus the 90-degree angle will have to equal 180. Now, since angle 1 is 17, because I told it to you, so you don't need to find the measure of angle 1. Angle 1 is 17 degrees here. Since you know that the measurement of angle 1 is 17 degrees, you can just plug it in and say 17 degrees plus the measurement of angle 2 plus the 90 degrees is equal to 180. Now, quick math, you can just take the 90 from both sides, and you get 17 degrees plus angle 2 equals 90. And now subtract the 17 from both sides, and you get that the measurement of angle 2 comes out to 73 degrees. So they make a 73-degree angle with their head over above their skis. All right. Thanks for taking the time to do the notes. Go ahead and take a look at the assignment. I've posted the assignment on the worksheets as well as the overhead. Have a good day, and I'll see you guys tomorrow.